Here we've been given what is called a system of equations to solve. That's where we have two or more equations and we're looking for the place where all of the equations would be true, where they're going to overlap. Now notice that this one we've been asked to do it graphically, so we're going to draw a picture of these two lines that we have. They are both lines that are in standard form since our degree, our highest exponent, is a 1. Now, since we've got standard form, the easiest way for us to draw it is usually to find the two intercepts. So let's see if we can do that for the first line, x plus y equals 3. If I'm going to find a y-intercept, the way I do it is I put 0 in for x. So this is going to be gone, and you end up with y equals 3. So the y-intercept is 0, 3 for this particular line. Now we can do the same thing to get the x-intercept. Let's put 0 in for y. That makes the y go away. We would end up with just x equals 3. So 3, 0 is the x-intercept. Now, once I know those two intercepts, well, then I can just plot them on a coordinate plane and draw the picture of it. Here is our y-intercept, 0, 3. And then here is our x-intercept, 3, 0. Now, remember what this line means. What the picture means is here are all of the solutions for that equation that we were just looking at. Anything that solves the equation shows up on this line. All right, let's go back and look then at the next equation. X minus y equals 1. When we try to find the intercepts for it, a little bit harder, but not bad. If I put 0 in for the x, this x is going to be gone. You've got minus y equals 1. Now, we don't want minus y. Let's solve that for y, dividing everything by -1. When we do that, we would get y equals -1. So when x is 0, y is -1, and that gives me a y-intercept of 0, -1. Let's do the x-intercept. Putting 0 in for y, x equals 1. So 1, 0 is the x-intercept. And here we'll draw that picture. And anything that is a solution to the equation we were just looking at now shows up on this red line. You can see 0, -1 and 1, 0, our two intercepts that we found. So now we said that anything that is on the blue line was a solution to the first equation. Anything that is on the red line is a solution to the second equation. So what could we say about this spot where the 2 points overlap? That's right. It's a solution for both of the equations. Now, that point where the two places are overlapping, the ordered pair that matches up with it, it's 2, 1. The x value is 2. The y value is 1. If we look at our original equations, let's see if 2, 1 would work in both of the original equations. 2 for x, 1 for y, 2 plus 1, that's 3. 2 for x, 1 for y, 2 minus 1, that's 1. So it did indeed work in both of the equations. The solution to a system of equations is the point where the two lines are overlapping. So we should express our answer with both an x and a y and as an ordered pair. Now, once we've done that, there are a couple of things that we'll want to use as words to describe our systems of equations. Anytime that you draw the picture and you actually see two distinct lines, we call this an independent line. The two lines are independent of each other. When you only see one line, then you would call it dependent instead. So 2 lines, independent. 1 line, dependent. Now, as far as our system is concerned, the words that we use to describe it, if they cross the 2 lines, if they cross at one point, we say that the system is consistent. C for cross and C for consistent. When they cross at one point, it is a consistent system. If they cross in every point so that you just had one line that you could see, then it's still crossing, so you still say that it is consistent. C for cross, C for consistent. If they have met in one place or in every place, then we say that it is consistent. If they didn't meet at all, if we had parallel lines, then there is no solution to the system of equations, and we would say that the system is inconsistent. Parallel lines, they don't meet. The place that they would meet would be the solution to a system of equations. Since they don't meet, we say there is no solution and they are inconsistent. Now, with these that crossed in every spot, they have an infinite number of solutions because anything that's true for one would also be true for the other. So when you see two lines, you say independent. If they crossed, then you say consistent. If they don't, you say inconsistent. If you see only one line, then you say dependent. And with one line, it is consistent.